The following is a production of New Mexico State University.
These ruins tell a story of ancient man and his harmonic relationship with the elements. What we know of this culture is not only written in the mud that makes up these walls, but also in the garbage that was discarded. 1,000 years from now, archaeologists may also be digging through our garbage. What will they deduct from our trash? Will we be known as a throwaway society? To tell us more about what we throw away is Kathy Tyson and Jenny Chavis with Albuquerque's Solid Waste Management Department.
The city of Albuquerque wanted to find out what was being generated, what was being put into our waste stream, and who was generating it. And so, with the assistance of a grant from the New Mexico Energy, Minerals, and Natural Resources Department, we hired a company to come in and help us with a waste characterization study. We wanted to use this study to find out what's going in and who's generating it, and that way we could better identify how we could divert materials from the landfill. What we came up with, the results of the study were that 34% of the residential waste stream was yard waste. That is the highest percentage of what's going into the landfill from the residential waste stream. Second to that was paper at 34%, just a little bit lower than the yard waste. Other organic materials made up 17% of the waste stream. Plastic was 7%, 4% was glass, 3% metals, 1% other, and 0.1% was hazardous waste.
The city of Albuquerque determined that we were going to add a green waste program to our integrated solid waste management program. The city decided to take a two-pronged approach to that. One was to educate the public and teach them about backyard composting. We did that in cooperation with the county extension service and master gardeners and other entities that were interested in environmental issues. The second part of the green waste program is going to be in working with several departments besides the solid waste management department. We're going to work with Public Works, who has purchased a grinder. We're going to grind up the green and yard waste, and we are going to then take that to our composting facility, and the compost is then going to be taken out to the parks and recreation sites that will be used as part of our integrated solid waste management program. By utilizing the composting facility, we will find that 34% of yard waste that is coming into the landfill will be diverted and used in the parks and recreation areas.
With the closing of many of our landfills and the cost of opening new landfills skyrocketing, we must find ways of reducing the amount of solid waste entering these landfills. Curbside recycling of things like aluminum cans, plastic, and newspapers is catching on. Some communities are also targeting yard waste and municipal composting programs. Yard waste for municipal composting can be collected either at the curb or taken to convenience centers. Steve Glass of Albuquerque's Public Works Department is in charge of converting this waste into finished compost.
The yard waste that's collected at our convenience center in the South Valley is ground up with an industrial grinder to produce the material you see back here. We receive about 37,000 pounds of that a day from the convenience center. That material is mixed with municipal biosolids, formerly called sludge, to produce an environment conducive to the growth of composting microorganisms. All the microorganisms involved are naturally occurring. We add nothing. We just provide the right environment for them. The mixture is created in a special little vehicle that mixes the materials together and deposits them in what we call a windrow, a long pile on the floor of our pilot composting facility. Each pile is built over an aeration trench in the floor, attached to a 7-horsepower blower that is operated by computer to maintain aeration in the windrow. We also have another means of aerating and mixing the windrows, which is the scarab, a dedicated turning machine that goes across the top of the windrow, mixes everything together, fluffs it back up, and injects air again. Temperatures of each windrow are carefully monitored at 3 locations continuously because federal regulations require that when we are composting biosolids or sludge, we have to maintain a temperature within the windrow, a naturally generated temperature of at least 135 degrees Fahrenheit for 2 weeks to make sure that any disease-causing organisms are thoroughly inactivated. It's basically a pasteurization process. After 2 weeks to 3 weeks of composting in the facility, the material is removed, screened, and cured for another week or 2 to allow colonization by actinomycetes that form humic acid. At that point, the product is complete and ready for distribution to our Parks Department for use in turf management applications.
Curbside collection of yard waste is, however, very expensive. Reducing the amount of yard and food waste entering the solid waste stream begins with you. It means a basic change in philosophy. We need to think in terms of reducing yard waste we generate and recycling what waste we do produce in our own backyards. Use of native plants and gravel on xeriscapes not only reduces the amount of yard waste that enters the solid waste stream, they also reduce the amount of water used in home landscapes. Water use in flower beds and gardens can also be reduced through the use of grass clippings and shredded leaves used as mulches. Grass clippings can also be returned to the lawn through the use of mulching mowers or push mowers. I prefer a push mower as it also reduces the amount of air pollution associated with gas-powered mowers. Grass clippings returned to the lawn reduce the amount of fertilizer needed for good growth, as well as the amount of clippings hauled off to landfills. Yard waste can make up as much as 20 to 30% of the municipal solid waste stream. Percentages may be greater during the spring pruning season, in the summer with lawn clippings, and in the fall when leaves are abundant. One of the most practical and environmentally sound methods of handling this waste is through backyard composting. Making compost is a speeded-up way of imitating nature's cycle of life and death. The leaves on this forest floor were deposited here last fall. Over the winter, microorganisms and various invertebrates have slowly converted much of this material into humus, a dark, loose, partially decomposed form of organic matter that not only conserves moisture, but slowly releases its nutrients for plant uptake. The only difference between finished compost and forest humus is time. Composting can occur either under anaerobic conditions or aerobic conditions. Anaerobic means without air, and the result means smelly compost. The organic matter in this sealed garbage can has no air and smells like rotten eggs. Smelly compost is not overly popular with neighbors. A few holes in the cans will help improve the situation. Aeration can also be improved by dumping the can out periodically and refilling it. Aerobic composting is the preferred method for backyard composting because it smells better and it's more efficient. Aerobic composting means in the presence of air or oxygen, which generally can be achieved by turning it periodically with a garden fork and by using some type of aerated composting bin. Almost any type of organic yard, livestock, or food waste can be composted. There are some exceptions, however, including any type of meat, fat, oil, milk, or cheese products which could attract pests, and pig, cat, or dog manures, which often carry disease organisms that could infect humans. Perennial weeds like bindweed, weed seed, and diseased plants should also be excluded, as compost may or may not heat up sufficiently to kill these weeds or diseases. Properly constructed and aerated, compost will generate heat, often as high as 140 to 150 degrees Fahrenheit. Heat in such piles is the result of rapid growth of thermophilic bacteria in the pile, which are generally active between 113 and 155 degrees Fahrenheit. Such heat will kill almost anything in the pile. Hot compost is no accident. It requires a good balance of air, water, carbon, and nitrogen in the pile. Low-temperature cyclophilic bacteria start the process out and are quickly replaced by mesophilic bacteria that are active at temperatures between 70 and 100 degrees Fahrenheit. Rapid decomposition of the pile by the mesophilic bacteria generate heat, which sets the stage for the thermophilic bacteria. As the pile cools down, various fungi and actinomyces take over. Both give the compost pile its faintly earthly odor. Other invertebrates that can be found in the pile include mites, centipedes, snails, and earthworms. Microorganisms in the compost pile require carbon for energy and nitrogen to synthesize protein. All organic matter contains both nitrogen and carbon. The amount of carbon in any particular type of organic matter compared to the amount of nitrogen it contains is called its carbon-nitrogen ratio. Optimum decomposition by microorganisms in a compost pile occurs when the average carbon-nitrogen ratio is 30:1. Some organic matter like sawdust, straw, and leaves are high in carbon, while other materials like grass clippings and kitchen waste are low. Organic materials high in carbon and those low in carbon should be mixed in the compost pile to come up with the ideal ratio of 30:1. Decomposition within the pile or bin can be increased by increasing the surface area of the organic material. Running twigs through a shredder or leaves through a power mower will decrease the size of the materials, thus increasing the surface area for microorganisms to grow on. Most compost piles aren't aesthetic masterpieces, so locating them in an inconspicuous but convenient location is appropriate. Be sure a source of water is nearby. As most compost is used in the garden, easy access to this area is essential. Minimum dimensions for a pile are 3 feet by 3 feet by 3 feet. Smaller piles won't heat up or decompose properly. The pile should be large enough to hold the heat it generates, yet small enough to allow air movement into the center of the pile. Piles taller than 5 feet are difficult to turn and may restrict airflow due to weight. Gardeners with large amounts of yard waste should consider constructing 2 or more compost piles or bins. 2 bins are convenient when turning the material, while multiple bins initiated at different times provide for compost at different stages of decomposition. Your choice of composting structures depends on your time requirements for finished compost, space limitations, and budget restraints. Making finished compost quickly requires the structures be adapted to turning compost frequently. Gardeners who are especially conscious of aesthetics may prefer rotating barrel composters. Though relatively expensive, these structures are less messy and produce finished compost more quickly than other structures as they can be turned easily. Another relatively expensive structure is a 3-bin composting unit. These bins can be made of sliding redwood slats, a combination of redwood slats and hardware cloth, or cement blocks. Heap composting is the cheapest method of composting, but it tends to take up more room and is somewhat messy. Holding compost units tend to be slower in terms of creating finished compost, as they tend to be turned less frequently, if at all. Materials are generally added to the holding unit as they are generated. To keep pest problems to a minimum, incorporate food waste into the middle of other yard waste. Holding units can be composed of redwood slats, wire fencing or chicken wire, snow fence, or cement blocks. The most popular composting technique involves alternating layers of organic material, soil, and fertilizer or manure. Layers can be laid down in either specially constructed bins or piles. We're going to start our pile with a mixed layer of corn cobs and sawdust. This will not only help provide aeration on the bottom of the bin, it will also help absorb any leachate that trickles down through the pile. Remember that both corn cobs and sawdust are high in carbon, so we next add a layer of sheep manure. This will help add the extra nitrogen we need to counteract all the carbon in the sawdust and corn cobs. If you want, you can also use nitrogen fertilizer like urea. I personally like to use livestock manure in my compost pile because livestock manure is another solid waste that can be a problem in our environment. Heavy concentrations in either dairies or feedlots can cause nitrate problems in both groundwater and through erosion. Generally, the larger the animal is, the lower the nutrient content is in the manure. I prefer sheep manure since it tends to be higher in nitrogen. Most feedlots or dairies will give you manure free if you load it yourself or charge a modest fee for loading it for you. After applying the manure to the layer of sawdust and corn cobs, it should be all sprinkled down with a hose. Remember that microorganisms in the pile need water to grow. The compost should have the consistency of a damp sponge. Piles will not decompose properly if you have too much water or too little water. We're next going to add about a 1-inch layer of soil. The soil will add the microorganisms needed to get the pile started. A little water will help move the soil down through the manure and the sawdust. Let's add some shredded leaves to the pile now. Instead of adding manure on top of the leaves, we're going to add grass clippings, which are also relatively high in nitrogen. I like to mix them in with the leaves so that they don't mat. After another layer of soil, I'm going to add a layer of straw and mix it in with some alfalfa. The nitrogen in the alfalfa will help counteract the carbon in the straw. I'm going to throw on some sheep manure and kitchen scraps just to make sure I've got enough nitrogen. Continue to add alternating layers of organic materials, fertilizer or manure, and soil until the pile is 3 to 5 feet high. Be sure to moisten each layer with water as it's laid down. This is particularly important for drier, coarser materials. The pile should heat up after a few days. To keep the process going, the pile needs to be turned. The more compost is turned, the faster it decomposes. One easy way to turn compost is to use this portable hail screen compost cage. Unsnapping the latches on the side and moving the cage over a few feet not only makes turning the compost easier, it can be used to move the pile around your garden so the leachate from the compost fertilizes your garden. A simple garden fork can be used to transfer the compost to the empty cage. When turning, move the outside material from the first pile to the inside of the new pile so it too will heat up.
Well, the whole process sounds rather complex. Let's put some master composters together with some kids, mix up all the elements, and see if we can come up with a well-designed compost pile.
Let's make compost!
Well, the whole process sounds a lot easier now, right? Wrong. Something can always go wrong. Let's give you a few tips on trying to troubleshoot your compost pile. If your compost smells like rotten eggs, it doesn't have enough air. Remember, that's called anaerobic composting. The solution is to turn the pile and to add some coarse material like sawdust or leaves to help aerate the pile. If your pile smells like ammonia, your organic material is too high in nitrogen, and again you need to add some more leaves. If your pile doesn't heat up, the pile may be too small, so you need to make it bigger. You may also be running out of water, so turn it and sprinkle it down. The pile may also not have enough nitrogen, so turn it and add some manure. Piles that don't heat up may also be low on air, so turn them. Another problem is cold weather. This can be solved by just covering the pile with some extra straw. One of the largest organisms that can often be found in compost is the earthworm. The common ordinary earthworm found in a garden will consume as much as its own body weight in soil each day.
The castings it leaves behind are a rich source of nitrogen, phosphorus, and potassium. The garden earthworm and the compost earthworm are, however, radically different. Red wigglers and the brambling worms can be grown in specialized bins or boxes to create vermicompost. I like to use a shallow redwood box that's well ventilated with a lid. Worms are placed in moist bedding made up of peat moss, sawdust, or shredded newspaper. Pockets of food waste can be buried in the bedding, and if the bedding is kept moist, the worms will eventually turn the food waste and the bedding into a high-quality soil amendment. Here to tell us more about making compost from earthworms is Jim Brooks.
One of the ways I like to compost my food waste is using earthworms or redworms. I let the worms eat all of my organic food that my household produces. There's several types of worms. The most prolific worm to use is called a red wiggler or a brandling worm. I believe the Latin name is Icenia foetida. They are different than an earthworm in that they don't burrow deep into the earth for their food. They live right on the surface or in the upper 18 inches of high organic content material. You can use redworms both in a pit or an open bed nursery. You can use them in compost bins, or you can actually do it right inside your house or in your garage in special constructed bins. Now this is compost which the worms have processed. It's fully stabilized and took approximately 3 months to process. It's very rich in organic nutrients, trace minerals, and humic acid.
Finished compost has many uses in a home garden. As you've seen, it's made up of a mixture of all kinds of plant materials and animal manures. Thus, it contains a broad base of both macro and micro fertilizer nutrients. Most of these nutrients are bound up in an organic form and are thus made available to trees, shrubs, flowers, and vegetables slowly throughout the growing season. Now, the quantity of any of these nutrients in compost is relatively low, so the major benefit of compost in your garden or yard is as a soil conditioner. Texture refers to the average soil particle size in any soil. Sandy soils have large soil particles and tend to be droughty and low in nutrients. If we add compost to these soils, it will improve both the water holding capacity as well as the ability to retain nutrients. Clay soils have small soil particles, which makes them sticky when they're wet. They tend to be poorly drained. Adding compost to these soils will tend to fluff them up, improving their aeration. Compost is most frequently applied to garden soils in the spring before planting. Compost should be liberally applied and turned under to a depth of 4 to 6 inches. Gardeners with limited compost should incorporate it only below the seed row. With garden peas, I like to dig a shallow trench, mix compost with soil on the bottom of the trench, scatter seeds throughout the trench, and then cover the seed with soil. As the seed grow, the trench is filled in with more soil and compost to help cool the roots. Twigs can also be recycled as a trellis for vines to grow on. Compost can also be used in the bottom of trenches for newly planted asparagus or potatoes. Crowns or tubers can be covered with more compost. As ferns and vines develop, the trenches can be filled in with more compost and soil. Beds that are developed are a rich source of nutrients and organic matter for developing roots and tubers. Compost also makes an excellent top dressing for lawns, trees, shrubs, and perennial flowers. Mulches around vegetables and plants help reduce water evaporation from the soil and cut down on annual weed growth. Compost will also cool the soil and buffer soil water fluctuations. If you're not into all the work involved in composting, there are some alternatives. Trench composting involves digging a trench and filling it up with shredded organic waste. The trench is then covered with 6 to 8 inches of soil. Depending on soil temperatures, microorganisms and earthworms will slowly convert these materials to usable organic matter. Compost holing is similar to trench composting except that it involves smaller areas. A sharpshooter or post hole digger can be used to make holes between plants like tomatoes. These holes can then be filled with food scraps and covered with soil.
Sheet composting in a garden involves applying raw composting materials directly on top of the soil in layers. Shredded organic matter can be applied between plants as a type of mulch and allowed to decompose slowly. Material can then be incorporated directly into the soil after frost in the fall. Recycling yard waste in your own backyard is limited only by your imagination. For example, these twigs for the pea trellis have been bound together with string into little bundles. I'll let them dry out this summer and then use them for kindling in my fireplace next winter. So remember, whether you're using twigs for a trellis, returning grass clippings to your lawn, or making compost, yard and food waste are a valuable natural resource that can be recycled in your own backyard.
The preceding was a production of New Mexico State University. The views and opinions in this program are those of the author and do not necessarily represent the views and opinions of the NMSU Board of Regents.